Welcome back, students. So in the last session we were discussing about the equations of motion, its numerical problems and so on. Now before we start our today's session, let me ask you something. How much do you weigh? You people will be having different answers, right? Some may say 50 kilogram, 65, 70 kilogram and so on. But what we popularly refer to weight is actually the mass. Is there any difference between this mass and weight? What you say the 60 kilogram, 50 kilogram, 75 kilogram is actually your mass, not your weight. That means your mass and weight is different. Then how can you really gauge your weight? That is what we are going to see today in this session. Okay? So let us see the differences, main differences between mass and weight. Mass means it is the amount of matter contained in a body. It is the amount of matter that is contained in a body is known as mass. Amount of matter contained in a body is known as mass. While weight is the force with which an object is pulled towards the center of the earth. So weight is equivalent to force. It is a force with which an object is pulled towards the center of the earth. So mass is the amount of matter, while weight is the force with which a body is being pulled towards the center of earth. So weight is the force with which it is being pulled towards the center of earth. Suppose if your weighing machine reads 60 kilogram. Okay, before coming into that, we have already discussed that weight is the force with which it is being pulled. So weight of a body is equivalent to the force which is equal to mg, where m is the mass of the object and g is the acceleration due to gravity. And from this equation we can easily get an equation for mass as m is equal to w by g, where w is the weight and g is the acceleration due to gravity. So weight is equivalent to force and it is equal to the product of mass and acceleration due to gravity. Suppose if your weighing machine shows a reading of 60 kilogram, then your actual weight is, the formula to find weight is W is equal to mg, that is 60 kilogram is actually your mass. So 60 into acceleration due to gravity is 10, which is equal to 600 Newton. We have already told that the force and weight are equivalent. So unit of force and unit of weight will be the same, that is Newton. So SI unit of mass is kilogram and SI unit of weight is Newton. So the reading what your weighing machine shows is actually your mass, not your weight. In order to find the weight of your body, you need to calculate it using the formula m into g, where m is your body mass and g is the acceleration due to gravity. Okay, hope it is clear. Hope those 2 points are clear for you. Now, the next difference between mass and weight is, mass is a scalar quantity, means it will only have a magnitude but no direction. Since it is a scalar quantity, the value of mass will never become 0, while weight is a vector quantity which have both magnitude and direction. Since weight is a vector quantity, the value of weight can be equal to 0 if acceleration due to gravity is 0, because we know that W is equal to mg. If acceleration due to gravity g is 0, in turn weight of the body will be also become 0. For example, in space, acceleration due to gravity is 0. So, the weight of an object in space will be 0. We feel weightless when we move to space. So, weight is a vector quantity, hence it can have both positive, negative and 0 values depending upon the direction. But mass will always have a positive value. It will never have 0 value since mass is a scalar quantity. That is the third difference between mass and weight. Now, the next difference is mass can be measured using a device called beam balance or physical balance. Mass can be measured using a device called beam balance or physical balance, and weight is measured using a device called spring balance. So, these are the devices to measure mass and weight. Now, the next difference is mass is universal while weight will differ from place to place. Universal means throughout the universe the mass of an object remains the same, but weight will differ from place to place. Weight completely depends upon the gravitational force on that place. Okay, weight completely depends upon the gravitational force of that place. So, as gravitational force differs from place to place, weight of an object also differs, but mass will always remains the constant. For example, your body mass will be the same on moon and on earth, but your weight will be different on moon and on earth due to the difference in gravity. The gravitational force on moon is very less compared to that on earth. So, as gravitational force differs, your body weight will also differ on moon and on the surface of earth. That is why as before astronauts fly onto a mission to moon, they will be acclimatized in a simulated lunar environment to ensure that when they land on moon, they can move around very easily even though the gravity is reduced. So, before mission they will be setting up a simulated lunar environment, and they will be allowed to stay there in that environment so that they get acquainted with such an environment of reduced gravity, so they can easily walk around on moon when they land over there. Okay. So, let us see how much the weight of an object differ on moon and on earth. Okay. Now, let us see how much difference is there between the weight on moon and on earth. For that, we need certain values, that is mass of moon is 7.35 into 10 raised to 22 kilogram, and radius of moon is a constant, again a constant value, which is equal to 1.74 into 10 raised to 6 meters. And mass of earth, the next constant value is 5.97 into 10 raised to 24 kilogram, and radius of earth is 6.37 into 10 raised to 6 meters. On substituting these constant values in universal law of gravitation, that is F is equal to g m1 m2 by r square, we can easily find the weight of an object on moon and on earth, because we know that force and weight are equivalent. So, in order to find the weight of an object on moon, use the equation Gm into mass of moon by radius of moon square. The universal law of gravitation, where G is the universal gravitational constant, M is the mass of object, capital letter M is the mass of moon, and R is the radius of moon. Substitute the values, that is G into M into mass of moon is given as 7.35 into 10 raised to 22 divided by radius of moon is 1.74 into 10 raised to 6 the whole square. On simplifying it, we get as Wm is equal to, on simplifying these terms, we get as Wm is equal to 2.43 into 10 raised to 10 into G into M, where M is the mass of the object. So, this is the weight of the moon that we got. Similarly, we can find the weight of the object on earth by substituting the values in universal law of gravitation, that is Gm into mass of earth by radius of earth square. That is G into mass of object into mass of earth is 5.97 into 10 raised to 24 by radius of earth is 6.37 into 10 raised to 6 the whole square. Again, on simplifying these terms, we get as We is equal to 1.47 into 10 raised to 11 Newton. So, weight of object on moon is 2.43 into 10 raised to 10 into Gm, and weight of the object on the surface of earth is 1.47 into 10 raised to 11 Newton. Now, let us compare these two weights, that is Wm by We, weight of an object on the surface of moon and weight of an object on the surface of earth, that is Wm is 2.43 into 10 raised to 10 G into M by weight of an object on the surface of earth is 1.47 into 10 raised to 11 into G into M. This Gm and Gm gets cancelled off. On solving this, you will get it as Wm by We is equal to 1 by 6, or we can say that weight of an object on the surface of moon will be 1 by 6 times the weight of the same object on the surface of earth. That is, the weight of the object on the surface of moon and weight of the object on the surface of earth will be different. Weight of the object on the surface of moon will be 1 by 6 times the weight of the same object on earth. For example, consider the weight of an astronaut on the surface of earth as 600 Newton. Now, let us see what will be his weight when he lands on the moon. We have the relation Wm is equal to We by 6. That is, weight of the astronaut on the surface of earth is 600 Newton divided by 6. He will only weigh 100 Newton when he lands on the surface of moon. So, weight of the object on the surface of moon and on the surface of earth are different. Since gravitational force on the moon is less, weight of the object on the moon will be less compared to that of earth. Hope it is clear. So, the differences between mass and weight are, The first difference is mass is the amount of matter contained in an object, while weight is the force with which the object is being pulled towards the center of earth. And weight can be found using the formula W is equal to mg, where m is the mass and g is the acceleration due to gravity. And the SI unit of mass is kilogram and the SI unit of weight is Newton. Now, mass is a scalar quantity but weight is a vector quantity which depends upon both magnitude and direction. Since mass is a scalar quantity, it will only have positive values. Its value will never become 0. Since weight is a vector quantity, it depends upon the direction too. So, weight can have 0, negative and positive values. Weight can become 0 if acceleration due to gravity is equal to 0. For example, in space, we feel weightlessness, we feel weightless. Since acceleration due to gravity in space is 0, the weight of the body will be also equal to 0. Now, mass can be measured using a device called physical balance and weight is measured using a device called spring balance. And mass is universal, that is throughout the universe the value of mass remains the constant. But the value of weight differ depending upon the gravitational force of that particular place. And we have compared the weight of an object on moon and on earth, and we got the relation as weight of an object on the surface of moon is 1/6 times the weight of the same object on the surface of earth. This Wm is equal to 1/6 into We. Hope the difference between mass and weight is clear for you. Thank you.